Hello, Course 3 students. Welcome to Lesson 4-9, Qualitative Graphs. As we continue to explore the question, how can we model relationships between quantities, we're going to look at the vocabulary, qualitative graphs. Real-world example, downloads. Emily is downloading photos from her digital camera to her computer. The table shows the percent of photos downloaded for several seconds. So here we have the number of seconds. This is our input. How many seconds we put into will raise the number of photos we are successfully downloading. So during which periods of time did the percent downloaded not change? So here we have 0, 0. After 2 seconds, it downloads 15 photos. After 4 seconds, so 2 additional seconds, 30 photos. From 4 seconds to 6 seconds, it froze. It didn't download any photos. But then from 6 seconds to 8 seconds, it made a big jump. Went up by 34 photos. Another 2 seconds, again it didn't load. But then in another 2 seconds, it made a jump of about 18. And then over here we have another jump on 2 seconds later of another 18. Okay, so we've just analyzed the table. So let's answer question 1. During which period of time did the percent downloaded not change? Between 4 and 6 and between 8 and 10 seconds. So here, between 4 and 6 and 8 and 10 seconds, there is no change. During which period of time did the percent downloaded change the most? So at which point did we have the biggest jump? I would say right here, right? It jumped by 34 seconds. So between 6 and 8. Between 6 and 8 seconds. Graph and connect the order pairs. So as I mentioned earlier, we have our X and our Y. So our input and output right here. So all of these values would be our X's and all of these values would be our Y's. And we have to label our axis vertically. I would say this is percent downloaded, right, all the way up to 100%. And along the bottom we have our time in seconds, right, along the x-axis. So let's mark that. So we label it time in seconds and percent downloaded, and we start to mark our order pairs. The first one is 0, 0. The second one is 2 and 15. So we go to 2 and we go up to 15. So when I label it, I have my points here: 2 and 15, 4 and 30, 6 and 30, 8 and 64, 10 and 64, 12 and 82, and 14 and 100. And now we're ready to connect our dots. So we try to draw these straight lines straight to the dots. And you can see we have a line graph that changes over time. Analyze qualitative graphs. The graph shown in a qualitative graph. Qualitative graph are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. So as you can see here, we had our time and we had our percent, and we're not including any numbers. We're simply just trying to show the changes over time. So as you can see, axes are labeled but do not include numerical values, no increments. And you can see the relationship between time and percent of photos downloaded. This is the relationship. We can see that it's increasing over time, but that it's not a constant rate of change. You can see that it plateaus every once in a while, and other times it has drastic jumps. Example 1. The graph at the right displays the water level in a bathtub. Describe the change in the water level over time. So it is increasing as we fill it up. Then it's full, and then it decreases, right? Almost at the same rate that it increased. So at time 0, the water level in the bathtub is 0. The water level in the bathtub increases at a constant rate. Then the water is turned off and the water level does not change. Finally, the drain plug is pulled and the water level decreases at a constant rate of change, a constant rate until the water level is back down to zero. So increasing, no change, decreasing. Now let's practice these two together, okay? And essentially what we're going to do is we're going to describe, right? We're trying to describe by analyzing these qualitative graphs. The graph at the right displays the temperature throughout the day. Describe the change in the temperature over time. We can see that the temperature both starts at 0, 0, okay? And it starts to rise, get warmer until maybe midday. And then again, it gradually decreases in temperature right back to where it started at the beginning of the day. Okay, so let's put that in words. I would say that over time, the temperature increases at a varied rate until it reaches a maximum. Then the temperature decreases at a varied rate. And the reason I'm saying varied is because it is changing. As you can see, it's not a straight line. Very much what we did when we were drawing parabolas and nonlinear functions. We would make a curved line, okay, to kind of join it and show a gradual transition from change to change. So let's try B. The graph represents revenue from a local clothing store. Describe the sales over time. Revenue is the money earned, right? The money that comes into the store. So here we have the number of sales over time. We can see that we had a nice increase of sales and then a slump, which means that there was no sales, and in fact the store lost money, or the sales went down. So sales were going up, great, and then they dropped, and then they went back up, spiked, plateaued, and then again went back up. So how can we say this in written words? I would say overall the sales increased steadily. They did. If we go from here to here, they've increased steadily. There are 2 periods of time when the sales decreased or remained constant. Remain is spelled wrong. There, remained constant. And you can see, yeah, the sales were going great, and then for a little while there, the sales decreased. They didn't sell as much in this period of time, and then it increased drastically, and they remained constant. The sales in this day would have been the same throughout those days. Depending on our increments, this could be a day-to-day, this could be just 1 week, this could be an entire year. So if it's an entire year, we can estimate that from this change to here could have been a month. And then again, it spiked back up. But sales over time have been increasing. And let's look at another main point for this lesson. Sketch qualitative graphs. Qualitative graphs represent the essential elements of a situation in graphical form. You can sketch qualitative graphs to represent many real-world functions that are described verbally. Let's take a look at a couple of examples. Okay, here we have tennis. A tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce height until it comes to a rest on the floor. Sketch a qualitative graph to represent the situation. Well, for step 1, if you were to do this, you would have to draw the axis. As you see here, the y and our x. You want to always put time along the bottom because we want to measure changes through time, right? So the changes move this way through time. And the distance from the floor can be our vertical axis. So draw the axis, label the vertical axis as distance from the floor, and label the horizontal axis as time. Then for step 2, as you can see here, sketch the shape of the graph. The distance from the floor starts out at a high value. So you can see here, yeah, we have to drop the ball from a certain height, and we want to see it bounce. Now, I don't know if a tennis ball will bounce this hard by just being dropped, maybe a rubber ball, but we'll just go with it. So, and it looks like they're just letting gravity do its job, right? Gravity's doing its job. It's not being smacked back down or anything like that, or no additional force is being added. So the distance from the floor starts out at a high value. The ball falls to the floor, bounces and rebounds to a height less than its dropped height. This pattern is repeated several times until the ball comes to the rest on the floor. As you can see, we have, this can be our y-intercept, right, our b value. And you can see that it goes down and it's bouncing and it's moving forward at the same rate each time, but at closer and closer to the floor. Let's look at another example, real world example. Number 3, a child swings on a swing. Sketch the qualitative graph to represent the situation. Okay, so now we draw the graph. How can we show it? Well, let's draw the axis. Label the vertical axis distance from the ground and the horizontal axis as time elapsed. Okay, time going. When we talk about time elapsed, most simplest definition is when the amount of time that passes from the beginning of an event to its end. So from the beginning from the time we start swinging to the end we're done swinging. So let's see. Sketch the shape of the graph. The distance from the swing to the ground starts at a low value because we kind of have to start, in the middle sort of thing. We're not really swinging. The child continues to swing and creates momentum. Each time the swing goes back until the child on the swing stops. So here we go. So the child is going back and forth on the swing. I guess let's just say the child were to go up, forward, and then as they're coming back, they go close to the ground, and then as they go back up, all the way to the back, they reach the highest point at the back, then they come back down to the ground, and now they're going to go to the highest point as they're facing forward to the other side of the swing. So that's what it would look like. Okay, and for this last one, let's do it together. A car is traveling at a constant speed. The car slows down steadily to come to a rest at a stoplight. Sketch a qualitative graph to represent the situation. So step 1, we must draw a graph. I'm going to use this space here to draw out my axis, my x-axis and my y-axis. So here I have, I will have time along the bottom, okay, because we always want to have time, changes in time, and we are measuring the speed, right, the speed of the car until the car comes to a stop. So we start, a car is traveling at a constant speed. That is the first part of the statement. So if the car is traveling at a constant speed, it's already going at that speed. So we have to start up high and have essentially a y-intercept, okay? I'm not showing any numbers, but I'm showing that it's going at a speed that is unknown. And it's traveling at that constant speed. And then the question said the car slows down steadily, it's not drastically, to come to a stop at a light. So if it's slowing down steadily, I'm going to assume that the speed is going down until it stops. So it would look something like this. So it goes steadily, and then it starts to step on the brake. It's going at a constant rate, and it's right here at this point, steps on the brake, and it's squeezing the brakes gradually, and the car is slowing down until finally it comes to a complete stop. So as you can see, this lesson was kind of easy in the sense that we didn't really do many computations. What we did was interpret situations and try to draw it in a qualitative graph with a line showing changes through time. Please take a look at our guided practice for class. If you have any questions, go back to the video and look at these examples, or simply come to class with your questions. See you then, everyone.